Welcome to Kubernetes tips and tricks to build and run cloud native applications. My name is Gary Singh, and I'm an outbound product manager for Google Kubernetes Engine. For the next 2 hours, we've got a jam-packed agenda. We'll cover tips and tricks and real-life scenarios from customers who are running cloud native applications on Google Cloud. Before we get started, just a little bit of housekeeping. You'll notice down below the video window, there's a chat window. If you have any questions during the session, please type them in there. At the end of the first session, we'll actually take your questions live, but we'll have folks monitoring this throughout the day to be sure to answer all of your questions. With that, let's get started. In the first session, we're gonna have a keynote from Johnny Karam, NSV, who is a industry analyst focused on microservices and cloud native applications. Additionally, Johnny also has a ton of cloud certifications as well, so we're honored to have him here. A little bit later, we'll be joined by Manu Batra, a product manager in GKE, and he's going to give us a demonstration as well, and then we'll have a chat with him to finish things off. So we take a look at the subjects that we're going to cover through today. We'll cover a little bit about what's the evolution of stateful workloads on Kubernetes. How are people running these today? What do we find that enterprises actually need more of? We'll have Manu come back and he's going to talk to us about backup for GKE, and then we'll take your questions live. With that, you see Johnny has joined us live on screen. So Johnny, great to have you with us today, and looking forward to your insights in this space. So maybe you can tell us a little bit about the evolution of stateful workloads on Kubernetes to date.
Absolutely. So it's my pleasure to be a part of this event. So I've been tracking this space for a while, almost since the launch of Kubernetes in 2014, 2015. So the first generation of stateful workloads on Kubernetes depended on host-based storage, things like empty dir and host path, which are, by the way, are discouraged today because of various reasons. But that was the first generation stateful workloads, taking advantage of the host-based storage. The second generation started to evolve in two different directions. One was the rise of distributed file systems, like ClusterFS and NFS, coming to the Kubernetes and cloud native world. And the second dimension was the rise of managed Kubernetes services in the public cloud, and surfacing the block storage devices and block storage services all the way to the managed Kubernetes clusters. So that was the second generation, predominantly driven by distributed file systems and block storage services. Then the third generation saw the evolution of stateful sets. Initially it was called pet sets, borrowing the analogy of pets and cattle, where cattle are more like stateless workloads and pets are more like stateful workloads. And eventually that got rebranded as stateful sets. And stateful sets brought the ability to run clustered stateful workloads like a MySQL cluster or a PostgreSQL cluster and so on. And stateful sets really made a huge transformation of running these stateful workloads, because they literally made it possible to run highly available, resilient, clustered databases and stateful workloads. That was the third gen. And the fourth generation, which we are currently experiencing, is bringing the best of both the Kubernetes universe and the traditional stateful workloads like databases. Earlier, it was all about just containerizing the databases or stateful workloads and running them as pods in a stateful set or in a deployment. But more recently, in the recent past, we started to see all these workloads getting more Kubernetes centric and becoming more and more cloud native aware. So that is the fourth generation. And these are, again, based on the concepts of custom resource definitions, the operators, and other advancements that the Kubernetes ecosystem has seen.
Great, Johnny. Seems like things really have come a long way in terms of running stateful workloads on Kubernetes. So let's drill down a little bit into this latest, the fourth generation, as you called it, and love to get your insights into how people are running stateful workloads today and what's the latest and greatest innovations in that space.
Absolutely. I think the first one that kind of transformed and changed the game is the availability of the operator framework and really making it more accessible. So the operator framework and the operators combined with stateful workloads brought in not just the workloads but also the ability to combine typical operations and day two activities that DBAs perform, that cluster administrators perform to the workloads. So if the previous generation was all about running databases and stateful workloads in a containerized environment, the operators brought in additional capabilities like backup and restore and snapshots and performing log rotation, log shipping, and all of that. So some of the traditional DBA activities are now combined with stateful workloads and wrapped inside the operators. And with that, workloads are becoming more and more aware of Kubernetes. For example, if you look at Spark, Spark has really become an integral part of Kubernetes clusters. There are a lot of cloud native Spark distributions and integrations that are available, including the one that runs natively on GCP. So that is one indicator, where workloads are becoming more and more Kubernetes centric and cloud native aware. This is actually helping enterprises reach to a point where database as a service is becoming a reality. Now, what do I mean by that? So when you look at managed SQL or managed database services like Amazon RDS or Google Cloud SQL or Azure SQL database, there are certain capabilities and there are some advantages that customers get when they consume these DB as a service offerings. Now, when you are running workloads by yourself in Kubernetes, you don't get to enjoy all the advantages of the managed DB as a service offerings. But with the ways of operators and the Kubernetes centric workloads, we are very close to delivering database as a service. So customers can really bring workloads, like Vitess and in fact Planet Scale DB, which are very cloud native. They are actually becoming available on Kubernetes, and it is possible to consume them like the way you consume managed database service. So currently, one of the biggest trends is delivering DB as a service on Kubernetes. And then there is this whole simplified Kubernetes centric operations. For example, how do I integrate application centric backups and application aware volume snapshots? And how do I back up the entire cluster of a stateful workload and restore it? So all those capabilities are coming, which are traditionally day two operations that are run by DBAs and workload owners.
Awesome. So, as we're seeing, in some of the latest studies, more and more enterprises have begun adopting Kubernetes or going to production. As they start to look at migrating some of their, or even starting new stateful workloads, what are you finding that they may need that's not provided today, say out of the box with Kubernetes?
There are quite a few challenges, and there are still some gaps that exist in the environment of running stateful workloads. The first thing is customers who are familiar with infrastructure as a service, by dealing with environments like Amazon EC2 or Google Compute Engine or Azure VMs. They are used to a workflow and a set of operations that they eventually became very comfortable with, like taking snapshots of your volumes, persistent disk volumes, restoring them and creating new EC2 instances or Google Compute Engine instances from these snapshots based on PD. Now, when they enter the container as a service world, they lose all those abilities, and there is a steep learning curve transitioning from IaaS, which is predominantly dealing with VMs and block storage, to container as a service, where managed Kubernetes services are being offered, and there none of the original capabilities of IaaS are working or they are not available. For example, how do I take snapshots of volumes attached to my Kubernetes cluster? And even if I take those snapshots attached to the worker nodes, it wouldn't be consistent and it wouldn't really replay the same scenario that works in IaaS. So there is a steep learning curve and a discrepancy between managing IaaS and managing CaaS, and this is what enterprises are struggling with. Second thing is, those who are used to a well-defined backup and restore strategy find it hard to deal with Kubernetes and managed Kubernetes service, because there is nothing like a very well-defined workflow-driven backup and restore strategy. That whatever you have been doing with snapshots and the entire workflow just doesn't work. It breaks when you switch over to cloud native. The biggest challenge is application portability and mobility, right? How do I move from one cluster to the other cluster? Now, forget about moving from on-prem to the cloud or one cloud provider to another cloud provider. Even within the same cloud environment, same cloud provider, moving from one region to another region, even after relying on Kubernetes, is very hard. There is no app mobility, there is no app portability. That's again because of the way the storage is diverged, between the underlying storage infrastructure and the way Kubernetes deals with these workloads. So that's one challenge: app portability and mobility, and then business continuity and disaster recovery with an acceptable RPO and RTO that is missing in the context of Kubernetes. If I am a DBA who manage large Oracle and SQL Server databases all his life, and if I am now tasked to manage databases in Kubernetes, I'm lost, because I don't know how BCDR works in the context of Kubernetes. That's another challenge. And interestingly, one observation that I made is all the managed service providers emphasis more on the infrastructure than the ability to manage the daily operations and workloads. For example, when I come to GKE, there is so much that I can do customizing my GKE cluster. I can install Istio, I can modify the CNI, I can basically click multiple checkboxes to configure my cluster, and it is very infrastructure centric. But once that is provisioned and I run a managed, not a managed, but a DIY stateful workload, again, I don't get any support from the cloud providers. So the emphasis and focus is more on simplifying and scaling the infrastructure than surfacing those advantages and abilities to the workload. I think these are some of the big challenges that are becoming a barrier for the enterprise adoption of stateful workloads in Kubernetes environment.
Well, great, Johnny. Really insightful, and perfect way to queue up our next guest, Manu, who's a product manager on the GKE storage side. He's going to give us a quick demo of something that hopefully will whet your appetite. Just getting into simplified operations, backup for GKE, fully managed product. So with that, we'll bring up Manu, and he's going to run us through a fantastic demo.
Welcome, folks. My name is Manu Batra. I am PM for GKE Storage. Today we'll be walking through a demo of backup for GKE service. So to start with, in the demo environment, I have two clusters, a cluster 1 and a cluster 3. So let's look at the workloads. On cluster 1, I have an Nginx deployment, and as a part of the backup, I will back up Nginx from cluster 1 and restore it on cluster 3. So let's start with creating a new backup plan. So first thing, I'm going to select what cluster I want to back up. I'm going to select cluster 1. I'm going to give it a plan name. Let's just call it plan 1 for simplicity. I will choose which region I want to store the backup in. I'm going to select US Central 1. Here I have a couple of more options. By default, I can take a backup of entire cluster, or I can select a specific namespace that I want to protect. There are some other options around to include secrets, persistent volumes, or I want to supply my own encryption key. I'm just going to go with defaults in this. I can also define now the backup schedule. So in this case, I'm going to define a cron expression, which is just take a backup daily. I can define a retention policy. So I'll select keep last 7 days of backups. I can also define a lock on the backups, which is until I can define a time lock to keep the backup from deletion till the time lock expires. I won't select it in this case, but that's an option. Here's a simple summary of all the options that I've selected, and I'm going to say create the plan. So now I have the backup plan created. So here's my backup plan, plan 1. For the demo, I already took a backup, which is essentially the same backup that we walked through, but just executed earlier. I'm going to go and restore this backup. So for restore, it's going to walk me through what the backup is, when it was created, what was the size. I'm just going to create a backup plan. Let me call it plan 2. You can also describe why you're restoring this backup. You can select a target cluster. So I'm going to select demo 3 as a target cluster. Next. Now, it's asking me about cluster scope resources. How do I want to restore cluster scope resources or not? And if there is a conflict, how should the system handle conflict? Should it preserve existing resources or override? In this case, since the cluster already exists, I'm going to select preserve existing resources. Then it's asking me, do I want to restore all namespaces in the cluster, or should I restore an existing or a specific namespace? Since I want to restore Nginx deployment, I'm going to restore a specific namespace called sales. And the system also wants me to specify what should it do on for conflict. Should it fail on conflict or roll back on conflict? I'm just going to select fail on conflict in this case. I can also define some rules around if my source and target environments are different, like if I want to reduce my replica counts or change replica counts, if I want to change from PD standard to PD SSDs. So this is the place I can define all those rules. So I'm just going to select restore, and the restore is executing at this time. I'm going to go to backup and restore, go to the restore section, and I can see that the restore is working. And it's telling me the duration is 40 seconds. Now let's go to workloads. And as I can see, the workload has been deployed on cluster 3. It's still spinning up the number of pods. Let me do a refresh. And wait for parts to show up as the restore is still working. I'm going to go back to backup and restore one more time. Check if the restore has completed, which it has. Now I'm going to go to workloads, and again give it a few more moments for the parts to come back up, and there you go. So I took a backup of Nginx from cluster 1 and restored it successfully on cluster 2. Thank you so much for taking time to walk through the demo, and please reach out to us if there are
Welcome back. And now we're going to go into a live Q&A session. I'm going to be joined again by Johnny, and Manu is going to join us after giving us that great demo. So welcome, Johnny and Manu.
Thanks, Gary.
All right, there you are. All right. So Johnny, we'll take some live questions from the audience in a second. But Johnny, after going through our points there and seeing that demo, what questions might you have for Manu off the top of your head?
Manu, great job on the demo. I really loved it. I think this is a great addition to the GKE stack on GCP. So one thing that's very obvious is most of the customers today use open source tools like Restic and Velero for managing the backups of stateful workloads. The moment I saw the demo, it actually strikes me that this is like Velero. So what are the differences between using an open source or a third-party tool like Velero versus using backup for GKE?
Awesome question, Johnny. And this is where a lot of customers, to your point, do rely on open source tools and scripting to take their own backups. One of the things we started hearing from customers is as they scale and Kubernetes stateful workloads become mainstream, customers are looking for more enterprise centric features in a fully managed environment. So, one of the key differences that we have built into the solution is it's a fully managed service where Google is managing the backups and the service itself. Another piece is we also built some really interesting enterprise features like ability to lock backups with time locks. So a lot of enterprise features are focused towards as customers scale their stateful workloads and enterprise policies come in, how they can reliably maintain the backups and still be in compliance. And those are the features that definitely make backup for GKE unique in the environment.
Excellent. Thank you.
Awesome. And all right, well, we've got some questions coming in. So maybe a little bit of a similar question, Manu, but a little more detail. Kunal wanted to know how is this different from, say, net backup tools, and how are Kubernetes snapshots play into this or compare with this?
Yeah. So definitely you can have snapshot at a storage layer, and CSI recently added volume-based snapshots, which can be enabled. But one of the things that we're trying to address as a full end-to-end backup solution is that how do you make data and Kubernetes objects and Kubernetes configurations as an integrated part of a backup? So what backup for GKE does is it takes all the Kubernetes objects in a cluster, a namespace, or an application as you define it, combines it with all the data that is attached to it in terms of PVPVCs, and backs it up as a single entity. So you not just have the data, you also have all your Kubernetes objects and configurations in the backup itself. So this is where it differs from like just a storage-based snapshot or through CSI, but this is more about a whole end-to-end backup solutions with policies. Another area is as you get into some more complex applications like crash consistent applications, which could require something as simple as QSing and unQSing an application pre and post backup. So those are some of the hooks that are built into the service, which enable you to take not only crash consistent backup, but also enable you to sequence app consistent backups. And the goal is that how can you make sure the backups are recoverable in a very graceful manner?
Great. Thanks, Manu. And Nishanti had a good question. So I know you kind of talked about this in the demo a bit, but can you go into the details about exactly what's included in the cluster backup, and maybe even share a little bit more about what options people have for picking various pieces to back up?
Sure. So as a part of cluster backup, we will pick up all namespaces, all applications that are defined within the cluster itself. Besides that, essentially the backup, we see it as two parts of a puzzle. One is we pick up all the Kubernetes objects, cluster scope resources and non-cluster scope resources like PVPVC mapping, storage classes. We pick up all the Kubernetes objects, and then we pick up any application dependencies like PVPVC mappings and the data that is attached to it. So essentially, at a very broad level, we look at backup as two parts. One is all the Kubernetes objects that are within the scope of a backup, whether a cluster or a namespace or an application, or plus the second part is if there are PVPVCs attached to it, we pick up all the data that is living in PVPVCs. In V1, we're supporting Google Persistent Disk, and in future we're also looking at supporting Google File Store and other storage media types.
Awesome. And I guess sort of in similar vein to some other questions, but Anoop wanted to know, is this similar to the capabilities that Portworx has?
So Portworx is a partner, and they also have a solution called PX Backup. which is also very similar. As far as I recall, they're also focused on application-centric backup. So it's very similar to those capabilities. But again, there are key differences around like how Portworx is able to support multi-cloud, and we are squarely focused on how workloads are deployed on GKE and how we scale GKE workloads cross region using the backup service.
Great. So Johnny, you've heard some questions and seen this. Wanted to give you another shot at Manu. What else can Manu tell you about backup for GKE? Do you have any additional questions for him? All right, I guess we'll take that in now. Another one, Manu. Diego was interested in, how can you actually schedule backups to run periodically?
Yeah, you can actually. So the system is very flexible. You can define a cron script, and the system will pick up a daily backup, an hourly backup, however frequency you want it to be. So as a part of the policy, you can define the frequency of backup and frequency of retention. So you can say take daily backups and keep last 30 days of backups or 31 days of backups. And it then becomes a circular queue. As new backups get onboarded, the last backups get off the queue itself. So you can define the frequency of backups and the retention time of each of the backups. So you definitely have that flexibility in the system.
Nice. And
yeah, I want to ask a question. So I missed connecting in the last.
Oh, no worries.
So Manu, one thing that I'm curious to know is, would this enable workload portability? So can I actually migrate off one cluster running in one region and restore it in the other cluster running in completely different region?
Yes, and that is a very common use case, Johnny, customers ask, especially a lot of retail customers that they're scaling for peak shopping season and the demand for different regions spike up. They want to be able to take backups of application running in region A, restore them in region E to scale their application. So that's a very common use case we see across customers. Some of the other use cases we also see are like CI/CD pipeline. I upgrade my environment every week. So Friday, I take a backup, I restore my backup, deploy all my updates, run over the weekend if updates run, and then before the next week starts, I apply those upgrades in production. So we definitely see regional scaling and CI/CD as definitely two critical use cases besides the traditional backup and DR use cases.
Excellent. Thanks, Manu.
Nice, Manu. All right. So I knew this question would be coming. So we got to put you on the spot, Manu. You are the product manager for this cool offering. Can you guess what the question is? When will this feature be released?
We just wrapped up the private preview for the service, and we're looking at public preview in December timeframe and GA early next year. So we're definitely moving very aggressively towards rolling it out globally across the region. So public preview, we're looking at December timeframe.
Awesome. That's only.
Please reach out to your Google rep, and we can figure out how we can get you more information on this.
Great. December's just around the corner.
It's right there.
So this might be it's a good question here from a noob. So, if I'm running, Mongo, his question is, how do we back up a PVC for a Mongo database running on GKE? So maybe talk a little, Manu, on how we handle, without interrupting those sort of workloads, right? And sort of the process for some of these replicated databases.
Right, and I think so. A lot of the databases can be crash consistent, where you don't really have to pause a database transaction to make it to take a backup. So this is where what backup for GKE has is ability to take crash consistent backups and app consistent backups. So if an application requires some kind of flushing the memory to move all the IOs to the disk, and then you take a disk level backup, that can be done, but you may or may not need to pause the application depending on what application likes. And then, of course, there could be a very simple crash consistent backup where the backup is happening at a storage layer and the application just continues just like any other function. They don't really, application has no idea that there is a backup happening at the storage layer. One of the things we're also looking for is how we enable more application centric templates. So that will have a little bit more guidance around how do you take a MongoDB or Cassandra backups and what kind of QSing usually is done on those. But currently, the framework provides the hooks, which can enable crash consistent and app consistent backups, depending on what application sees necessary.
Nice. And Ravi Chandra had a good question for us. Are these backups cloud agnostic today?
So today they're not. When we take a PD backup, they're incremental for 999, and part of the reason they're incremental and very efficient is because they are in the native Google persistent disk format. So that's something in future, but for as it stands today, all the backups are in native GCP format.
Great. And all right, we got time for a couple more here. So Martin wanted to know, so if you create your Kubernetes resources using, say, GitOps tooling, how can you back up and restore, well, only the persistent data that's in the cluster? And then how would it also deal with stuff in a cloud database outside the cluster?
Right. So currently the service is limited to GKE. We are not orchestrating a backup across a managed service like Cloud SQL, or if you're using other Google managed services. Now, to your other question, which is around how can you do a GKE backup where your application is running? So this is where you can actually define at an application layer, you can define scheduling, you can define the location of backups. And by default, when you take a backup, we actually back up the config by default. But when you restore, you have a choice to only restore data and not restore all the Kubernetes objects. So during the backup time, we'll back up config plus data. But at restore, you can tell the system that my cluster is fine. I just want to restore PVPVCs and the data that is attached to it. So definitely at restore time, that flexibility is built in. If that's a use case and that's something that is required given the restore scenario that you're executing on.
Great. We did have I think one other similar question. Which Manu covered earlier, which is as you said, right now this is specific to GKE running on GCP, right, for all of our backups. And then I think Tom had a question here, and you may have answered this before, but backup restore does deal with the PVCs. I mean, we don't have block storage; it's file storage, but it basically any persistent volume that we have for PDs today, right, is actually backed up.
That's right. Any PD with like balanced PD, standard SSDs. So any PDs that are attached to a specific workload or a cluster or a namespace, we will back it up. And of course, you can tell the system you don't want to back up PVPVCs, but by default, we include all PVPVCs attached to it. And in V1, we're supporting persistent disk.
Awesome. And Johnny.
Yeah. So the more I hear about this, Manu, the more I get this question. So is this completely independent of volume snapshots, or is there a mechanism to seamlessly extend the CSI volume snapshots with GKE for backup? Backup for GKE, I'm sorry.
Yeah, no, that's fair. So the underlying plumbing, the intent is to make it all seamless. The intent is to make the service, we just back up everything that is inside or attached or the cluster is dependent on, whether it is all the Kubernetes objects and the data. We didn't want to expose the mechanisms around like whether we're using CSI underneath or using like native PD APIs. But a lot of the mechanisms are similar, but the service is designed to be more consistent across the board to say we just back up everything. And One of the other things, Johnny, I would also mention is that when you take PD snapshots with, let's say, CSI, those PD snapshots are visible in PD control plane. And a user can go in and hopefully not often, but maybe accidentally delete a snapshot. But when you take a backup with backup for GKE service, the only way to manage the backups, whether it is managing the lifecycle of data, managing lifecycle of the backup, is through backup for GKE control plane. And this is where the whole thing about Kubernetes objects plus data being a single entity and managed as a single entity becomes critical. So definitely users who are looking for volume-based snapshots can use CSI, but for the backup function, the way backup for GK design, it basically gives you that enterprise level controls to be able to protect and have policy-based backups.
Awesome. So I have one follow-up question. So will this get extended to Anthos running in vSphere and other clouds? Would I be able to back up workloads running on Anthos with the same workflow?
Yeah, I think that's definitely something we're looking in future, how we make it seamless across workloads running with Anthos and hybrid and multi-cloud environments.
Got it. Thank you.
Great. So we'll wrap things up. If we didn't get to your questions, don't worry. They will be in there. We'll answer them in the chat forum. Manu will or myself or whoever will get back to it. We have people manning out there. And with that, I'll just make a comment. Manu knows that I'm really excited about this feature. I've been bugging him since I joined the company about it. So it's great to see it. And with that, wanted to thank the two of you for joining us this morning. Fantastic session. Johnny, thanks for the insights. Manu, thanks for showcasing some cool innovations. And with that, we'll take a break and we'll be back with our next session on developing applications with Autopilot.
Thank you.
Thank you all.